All right, who's ready for some geometry? This video will cover 13-3 special right triangles. Here in this triangle, we've got angle L is 40 degrees. We have the side opposite that angle, and we want LM, I'm going to call that X. And then we want side NL, I'm going to call that Y. So let's look down here again at the 40-degree angle. We have the opposite side. We want the adjacent side. Opposites and adjacents mean tangent. The tan of 40 degrees equals opposite 3 over adjacent x. We'll multiply both sides by x and then divide by the tan of 40. So x is 3 divided by the tan of 40 degrees. And that means x, which is also side ML, is approximately 3.6 inches. Okay, now we're back at the 40-degree angle. Again, we have the opposite, and now we want the hypotenuse y. Opposites and hypotenuse means sine is involved. The sine of 40 equals opposite 3 over hypotenuse y. Multiply by y, divide by sine of 40. So y is 3 divided by the sine of 40 degrees. So that means side y, or the hypotenuse NL, is about 4.7. Okay, so let's dig in here. The title says investigate 45, 45, 90 triangles. So our goal here, discover the relationship that always apply to an isosceles right triangle. A, below is an isosceles right triangle, ABC. Angle C is the right angle. Before we begin, what are the measurements of A and B, and how could we know that without measuring? Explain. Well, there's 180 degrees in a triangle. 90 degrees are used up in angle C, so that means A plus B have to add up to 90 degrees. Now notice that the sides here are marked congruent. AC is congruent to BC, and we had the isosceles triangle theorem. Isosceles triangle theorem basically says the angles across from the congruent sides will also be congruent angles. So that means A and B will be congruent, and there's only 90 degrees to split between them, so each angle has to be 45 degrees. Okay. Part B, label one of the legs' length as x. So I'm going to call AC x. And then it asks, what is the length of the other leg? Well, if AC is x, then BC also has to be x, because it's isosceles. Part C, let me slide some of this stuff up so I have a little room. Part C, can we determine the length of the hypotenuse in terms of x? Oh, you betcha. So let's see. Pythagorean theorem says a squared plus b squared equals c squared. Well, a and b are the legs, and we're calling our legs both length x. So a squared will become x squared, b squared will also become x squared, and then c squared is our hypotenuse. So let's add these together. X squared plus x squared is 2x squared equals c squared. Now we want to get c by itself, so I can root this side quite easily and just have c equals. Now over here we got a couple terms. Let's square root the x squared separately. Square root of x squared is just x. And when we root the 2, it's just stuck as the root of 2. So our hypotenuse, c, is root 2 times whatever length the leg was, x. Now, I don't know where part D went. Here's E. Given any one side of an isosceles right, can we solve for the other sides? How would you find the hypotenuse quickly if only given the length of one leg? I'm going to draw a quick 45, 45, 90 down here. So it says, given one side, how can you solve for the other two? Well, let's say I got this leg. The other leg will be the same, and the hypotenuse will be that same length times the root of 2. So let's say I have a triangle, this side is 5, this side is 5. The hypotenuse would be 5 roots of 2. Now what if they gave us the hypotenuse Maybe the hypotenuse is 7, and I want to find out the length of the legs. Well, we multiplied by root 2 to get to the hypotenuse. So to go from the hypotenuse back to a leg, we will take the hypotenuse and divide it by the root of 2. So here at the end, all 45, 45, 90 triangles are known as right isosceles triangles. So here's our official 45, 45, 90 triangle theorem, and our fill in the blanks. Say in a right isosceles triangle, the ratio of the angles is 45 to 45 to 90, and the ratio of the side lengths is x to x to x times root 2, where the x root 2 will always be the hypotenuse. So if we look over here at the picture, if I have this leg and I want to jump to the hypotenuse, I multiply by the root of 2. If I have the hypotenuse and I want to jump to the leg, I'm going to divide by the root of 2. And remember, the legs are always the same because it's isosceles. Okay, here's a couple of examples to try out. 2a, find the unknown side lengths. Well, this is 45, and we have our right angle. So z is also 45, and that means this side, yz, or yxy, will also be the same as yz. It's also root 3. Now, if I want to jump to the hypotenuse, I'm going to take the leg and multiply it by the root of 2. Root 3 times root 2 is root 6. Now, when we come over here to part B, we have a 45, 45, 90 triangle. Here we have the hypotenuse, but neither of the legs. So if I'm on the hypotenuse and I want to jump to the leg, I'm going to take the hypotenuse, root 5, and divide it by the root of 2. Now, this is fine here, but since it's a square root divided by a square root, we could make one big root of 5 over 2. If you don't like fractions, you prefer decimals, the root of 2.5. Or we can plug it in the calculator and get an approximate decimal, about 1.58. So let's see, over here, we sort of had, what was this? X to x to x root 2. And in this one, our x's were both root 3's. And then we had here, root 3 times root 2 would be root 6. For this 45, 45, 90 triangle, we have x and x root 2. So our x root 2 here, this was root 5. And then these x's are legs. Let's just put in the decimal, 1.58. There we go. Now here, we're going to check out our second special right triangle. This one is 30, 60, 90. So it says, discover the relationships in a right triangle formed as half an equilateral triangle. So below here, we have equilateral triangle ABC. Equilateral means all sides, all angles will be the same. So it says the side lengths are all 2x. What are the measures of angles ABC? Well, there's 180 degrees to go around. There's 3 angles. Each angle will be 60 degrees. Angle A is equal to angle B is equal to angle C, and they're all 60 degrees. Now, I know what you're thinking. I thought this was 30, 60, 90. I thought we were doing right triangles. Well, that's about to happen. B, draw the altitude AD from vertex A to side BC. So I'm going to get my red pen, and we're going to drop an altitude from A down to BC, and here is our right angle. Label the intersection point D. How does this divide the triangle? Well, it divides it into 2 congruent triangles, and also angle C will still be 60 degrees. Here's our 90-degree angle. Angle A has been bisected. So angle A here is now our 30-degree angle, and we have our 60 and our 90. And this whole side down here was 2x, but we split it by dropping our perpendicular. So now this side here is just x. And what I'm going to do to pull out of that other triangle, I'm going to just sort of redraw it here. So this is x, this is 2x, here's 30, and here's 60. So I already explained it. We split angle A, and we split side BC. Examine one of the triangles created by the altitude. What are the three interior angles? Oops. So we already got them labeled here, 30, 60, 90. What is the length of the base DC? So DC, yeah, we already figured that out. The whole side was 2x. We chopped it in half. So what is the length of base DC? DC equals x. How can we find the length of AD? That's our altitude. Well, it's back to Pythagorean theorem. This leg squared, and I'm just going to call this one B, plus this leg squared equals hypotenuse squared. So we're going to go x squared plus b squared equals c, which was 2x. Now notice I did put that in parenthesis. The length of our hypotenuse is 2x. We got to square the whole thing. So x squared just stays x squared. B squared is our unknown. 2x squared would be 4x squared. Now subtract x squared from each side. So now we've got b squared equals 3x squared. And to get b alone, we're going to root. The square root of b squared is just b. Let's square root our x squared separately. That'll just be x. And then we square root our 3. So how can we find the length of AD? That was just Pythagorean theorem. So our missing side b is x times root 3. Whoa. So that side b equals x times a root of 3. Okay, now let me just back up here and show you something. Well, actually, I can just do it off of this. Yeah, let's go through the fill in the blank, and then I'll point out some stuff on the picture. In a right triangle, where the ratio of the angles are 30 to 60 to 90, the ratio of the side lengths are x to x times root 3 to 2x, where the 2x is always the hypotenuse. So now let's concentrate on the figure. 30 degrees is across from the small leg, and then we've got the big leg, and we've got the hypotenuse. So let's say we're standing on the short leg, and we want to jump to the hypotenuse. We multiply by 2. If I'm on the hypotenuse and I want to jump back to the short leg, I would divide by 2. I'm back on the short leg and I want to jump to the long leg. Well, I take the short leg and multiply by root 3. If I'm on the long leg and I want to jump back onto the short leg, I divide by the root of 3. So again, from short leg to hypotenuse, we times 2. Short leg to long leg, multiply by root 3. If we go in the other way, we divide by those same quantities. So if one side length of an equilateral triangle is 4, draw this nice and big. So the side length of so all sides are length 4. What is the length of each leg and the hypotenuse of one of the triangles created by the altitude and the base? So I'm going to drop my altitude. Here's my right angle. So I'm on the hypotenuse. If I want to jump here to the short leg, chop this in half. Short leg would be 2. Now I'm on the short leg and I want to jump to the long leg. That is the short leg times the root of 3. There's our side lengths just by jumping around on the triangle. So I guess we could write this from the theorem. We had short leg to long leg to hypotenuse. We know our short leg here was 2, so our next side would be 2 root 3, and then 2 times 2 is 4. Short leg, long leg, hypotenuse. All right, example 5, find the unknown side lengths. So here's our 30-degree angle. That means we are across from the short leg. So short leg is 2.5. Oops. Let's jump to the hypotenuse. That would be 5. And then from the short leg to the long leg, that would be 2.5 times a root of 3. Root 3. And let's see if you're curious about this longer leg as a decimal. I've got a 4.33. Short leg 2.5, hypotenuse is 5. Now in 5b, we are starting with the hypotenuse. So here we are across from the hypotenuse. So our short leg is going to be across from that 30-degree angle. There we go. So our short leg is over here, and it's going to be half the length of the hypotenuse. Half the hypotenuse will be 4. And now that we know the short leg here is 4, the jump to the long leg will be 4 times a root of 3. And that is about 6.93. Okay, practice time. Pause the video, try these problems, and then fire it back up and see if you got it right. Okay, so here in this first one, we've got 2 to 2 root 3 to 4. Well, that is our 30, 60, 90 triangle. Here we see a repeat, 5, 5, 5 root 2. So that'll be our 45, 45, 90 triangle. All right, find the values of x and y. So here this time we've got the long leg. So if I want to find x, I'm going to take this long leg and I'm going to divide it by the root of 3. X is equal to 9 divided by root 3. And that means x is about 5.196. Now to get y, again, here we are on the short leg. We know that it is 9 over root 3, or this decimal. To jump to the hypotenuse, we're just going to double that. So this times 2 is about y equals 10.392. Number 3, the logo of the recycling resembles an equilateral triangle of side lengths 6. What is the approximate height of the logo? So we want, I'm going to use red ink, the height of the logo would be this red side. Well, it is an equilateral triangle, so now we've got a 30, 60, 90. The whole sides were length 6, so if that's my hypotenuse, the short leg is half of it, 3, and then my long leg will be 3 roots of 3. So our 30, 60, 90, we have x root 3, and 2x. Well, our x value here was 3. That was our short side. Longer leg, 3 roots of 3. Hypotenuse, 2 times the short leg, or 6. Okay, number 4, find the values of the variables. Ooh, now here's a weird looking setup here. But if I connect from right here, straight down, we have a rectangle, and then we'll have a 45, 45, 90 triangle. So this side here across from this 3, this will be a 3. And then this side here will come across the rectangle, so this side is 4. All right. We know this leg is 4. And if it's a 45, 45, 90, this also has to be 4. So our variable u is these two added together. U is equal to 7. Now we also want to find t. That's the hypotenuse in our right triangle here. So that hypotenuse t is going to be leg 4 times the root of 2. As a decimal, about 5.66. All right, in part B, let me move this out of here. So we've got E and F and G, and it looks like we have both triangles. Here is our 30, 60, 90 up top. So let's start with this one. We have the long leg, 9 root 3. So if we're going to jump back to the short leg, we would divide that by the root 3, and that looks like E is going to equal 9. So the short leg E is 9, and then I want to get the hypotenuse F. Well, F is that 9 times the root of 3. So F equals 9 root 3. Now, I'm going to switch to blue ink. We're down below in this 45, 45, 90 triangle. And this side F that we just found as 9 root 3, well, that's the hypotenuse. We want to jump from the hypotenuse to the leg, G. If we had G, we would multiply by root 2. Now we're going in the opposite direction. So G is going to equal 9 root 3 divided by the root of 2. Ooh, hold on, back up. I made a little mistake there. When we found side G, if I just back up to right here, but the short leg was 9. The hypotenuse will be twice that. So F is equal to 2 times 9, or 18. My bad. Now the hypotenuse is 18. We want to jump from that hypotenuse back to a short leg. So we would multiply the short leg by root 2 to jump to the hypotenuse. Now we're going in the opposite direction. So the leg G is going to be 18 divided by the root of 2. And as a decimal, that's about 12.73. Okay, one more problem to go. The body of a dump truck is raised to empty a load of sand. How high is the 14-foot body from the frame? So here is our 14-foot body, and we're trying to find our height above the frame. So we're going to draw a couple pictures here. First, we're going to raise the dump truck up at a 45-degree angle. And in the other one, we're going to raise it up higher to a 60-degree angle. Again, in each of these, that blue line here in the picture, this is 14 on both of them. So in each case, we have the hypotenuse, and we're trying to find this longer leg. Okay, so in the first one, if I had the leg and I jumped to the hypotenuse, I would multiply by root 2. So in this case, we're going to go the other way and divide by root 2. Let me just call both of these sides x's. So if we knew what x was, we would multiply. So we could do x times the root of 2 is equal to 14. So to get x alone, we would divide both sides by root 2. 14 divided by root 2, that is about 9.9 feet. Okay, now in the next one, we've got 14 as the hypotenuse. This would be the short side x. And then this side here would be x times the root of 3. So remember, when we jump from this longer leg, or hold on a minute. When we've got the hypotenuse, let me back that up. We've got the hypotenuse, and we're going to jump to the short leg. That would be down here. That would be half the hypotenuse, 7. And now we're going to jump from the short leg to the long leg. That's where we multiply by root 3. So it'll be 7 times the root of 3. And on a calculator, that would be about 12.1 feet. There we go. That was the last problem. Hope you found the video helpful.